This is Caesar, and he had a cipher. Let's look at clues towards building Caesar's cipher. For the first step, receive a command line argument as input, then validate if it is a single argument and if it is a digit. If it is valid, then prompt the user for the plain text. Then isolate each character in the plain text. Find the alphabetical position of each character in the plain text. While doing so, do take care to preserve the case. Then shift the characters based on the value of the key. During this step, we need to wrap around the alphabet if required, and finally, we can print the final encrypted text. Now follow along as I'll give out clues to solve this problem. The first problem that I ran onto while trying to solve Caesar cipher was on how to validate whether the command line input was a digit or not. Upon searching the internet and finding a Stack Overflow post, I ran into this code, and it has helped me to solve this problem. Let me help you understand it. For this, we are using the isDigit function that we can include from the ctype.h library. So be sure to include the ctype.h library into your code. Now, let's understand what's going on over here. The isDigit function accepts a character as its input and produces a Boolean value of true or false. If the character is a number, it returns true, and if it is not a number, it returns false. When I found out of the isDigit function, I wrote the code like this at first. But this doesn't produce the output that we want. Why? Because if the key is something like 12A, then while we are looping through the key, 1 will trigger the response of isDigit as true, and it will return 1, effectively closing this function. But that's wrong. 12A is an alphanumeric input and it is not a complete number. To solve this, we are going to check if it is not a digit, and if it is not a digit, we are going to return 0. You have to understand that returning 0 is akin to returning false, and returning 1 is akin to returning true. We'll loop through each character and check if it is not a digit, and then return 0 if not a digit is true. Over here, we'll return 1 if this entire check did not trigger is not a digit. The next issue I faced was how to easily figure out the alphabetical position of each letter within the plain text. To find this out, we have to create a for loop, and this loops through every letter within the plain text, or this loops to every character within the plain text. Mind you, sometimes the plain text may consist of even a sentence, and the character may consist of blanks. So first we are going to check if these characters are alphabets using the isAlpha function from ASCII-type.h library. Pass on the value of plain text, plain, and if those are alphabets, we'll run our code. Else we simply need to print that character as it is. Now over here, we need to find the alphabetical position of plain I. To do this, we can say create an int, hold it old position, and that be equal to whatever value of plain is minus the alphabet A. Because A will be decoded into ASCII as 65 and plain I will be a letter, this code will actually get us the position of plain I within the alphabet. Now, a slight change that we can make to this code is to check whether plain I is an uppercase letter or a lowercase letter, and change the value of A accordingly. For that, let's just declare a character called alphabet and say that it's actually equal to small a. But if plain I is an uppercase letter, if plain I is an uppercase letter, then alphabet is going to be capital A. Now we can subtract alphabet from plain I to get the alphabetical position of each letter within the plain text. The next task is to use the formula. The next task is to find the new position of the letters after we apply the key. For this, we'll have to add the old position to the key and then apply modulo 26 on that. This is going to be an int called the new position. Now the key here is actually argv1, but as we know from but we do know that argv1 is actually a string, and a string cannot be added on to an integer. So we are going to use this function, a toy function from standard library that we do need to include. We are going to use the toy function from standard library to convert argv1 to a string, and then use the modulus 26 operator in it to wrap around the alphabets. That is, if old position is, let's say, 25 and argv1 is a string like 5, then 25 plus 5 is going to be 30, and modulus 26, 30 modulus 26 is going to be 4 because modulus returns a reminder. Now let's just print f %c. Let's print out the alphabet in this position. Let's create a new character. Let's create a new character called cipher and say that it is going to be the alphabet at this position. How are we going to get it? If the old position was equal to plain text I minus alphabet, then the char cipher is going to be new position plus alphabet. We just need to printf the character alphabet cipher, and now let's check our function. Have implemented this in a practice file. You should implement it as per CS50 specifications and not like this. Make practice. There's an error. Don't validate key. There is an error because we did not create the prototype of this function. I did not create the prototype of this function. Set off this code. Be sure to be wary of such errors. Make practice. Another error. This is a string. The key is 8. Plain text is hello. These are the few clues on how to solve these problems. And that's it. With these ideas, you have everything you need to solve Caesar Cipher problem set. If you're still stuck, that's okay. Don't give up. Struggling with a problem set doesn't mean you're bad at programming. It means that you're learning. Persistence matters more than intelligence when it comes to coding. Keep pushing, keep experimenting, and I'll see you next time with the next problem.